Welcome to another tutorial. This is a follow-up of the indeterminate limit using L'Hopital's rule to solve such case. We have gone over in the previous session that L'Hopital rule looks like this. When you have an original function that you end up with an indeterminate form, but it can be written in a quotient form. Then what you can do is you can take the derivative of each part of the quotient, so the derivative of the top, derivative of the bottom, apply the same limit. And you can do this multiple times until you finally get to the right answer. So let's take a look at this particular variation. We have x squared times e to the negative x, and as x approaches infinity, we end up with infinity, right? Because infinity going to x squared, infinity squared is infinity, times e to the negative infinity. E to the negative infinity, right? Remember, e to the negative infinity, e to the negative x look like this. It will go as x approaches infinity, this value is going to approach 0. So infinity times 0, this is an indeterminate form. So let's rewrite this a little bit, but this is not in a quotient form, so we can't really apply L'Hopital's rule. We had to make sure that this is written in a quotient form. So let's rewrite this in a quotient form. Limit as x approaches infinity, x squared. Now e to the negative x is 1 over e to the x. So we can apply this to e, divide by e to the positive x, right? So now, if you look at this problem, the top is infinity, the bottom e to the x as x approaches infinity, right? This is this function now. As x approaches positive infinity, it gets higher and higher. So it's infinity. So now this is an indeterminate form. I haven't applied the L'Hopital's rule yet, but I need to make sure in order to apply L'Hopital's rule to this problem, indeterminate problem, I need to make sure that it's written in a quotient form. Okay, so now we can apply the L'Hopital's rule, which is to take the derivative of the top, take the derivative of the bottom, apply the same limit. So derivative of the top is 2x, the bottom is still e to the x, right? Derivative of e to the x is e to the x. Take the limit as x approaches infinity. We end up with infinity over infinity. Well, we got infinity over infinity. It is still an indeterminate form, but it is still a quotient form. So if it's still a quotient, then we can again apply the L'Hopital's rule to this repeatedly. So then take the derivative of the top, which is 2, derivative on the bottom, e to the x, limit as x approaches infinity. Now we end up with 2 divided by infinity. Now 2 divided by infinity just means that 2 will divide by a value that gets bigger and bigger and bigger and bigger. A finite value divided by something bigger and bigger and bigger and bigger will eventually becomes 0. So this answer is 0. See you next time.